Hi everybody, this is the Math 31 optimization review. This is question 7a. If it looks like I've already done this question, it's because the truth is I already have, but I made a mistake. I accidentally dropped a square at one point, so I got to redo this question. Okay, so we're talking about two planes flying over Villeneuve Airport. What we want to do is we want to graph this thing out to start off with. Okay. The first plane passes over the airport 10 minutes prior to the other plane, okay? And we're told the speeds at which the two planes are traveling. So the first plane is going east, so it's going over here. So in a few minutes it's going to end up over here. So this is going to be plane A. And we know this plane is going 300 kilometers per hour. Now the other plane was coming south, okay? And we know that 10 minutes after A hits here, so an A hits here and goes this way, that B is going to hit here, which means B must be north, okay, of A. And it's going 420 kilometers per hour. Now, we can determine very easily how far north it is because 10 minutes is a sixth of an hour, and a sixth of 420 is going to be 70. So we know that this distance here will be 70 kilometers. Okay. Now, in a few minutes, B is going to be down here. And so the distance between them we'll call D. Okay, and we can build an equation for determining the value of D as a function of time. And that's really, when we talk about optimization problems, that's really what we're trying to get you to do here. So the distance between them squared, okay, and honestly that was the square that I forgot. A little embarrassing, but anyway, the distance between them squared is going to equal, well, the distance that plane A goes. Okay, and in any given time, A is going to go 300 kilometers an hour times time, and we'll square that to get the distance that it goes, to complete the Pythagorean theorem, plus, now what we need is the distance that plane B is from the right angle here. And that's going to be 70 kilometers minus 420 times time, and that will also all be squared. Now, I am not, at this point, too motivated to expand that all out and whatnot, so what I'm going to do here is I'm going to take the derivative of this, kind of the way it sits here, and I'll just apply the chain rule. Okay, so what we're going to do here is I'll take the derivative of d with respect to time, so this is going to be 2d d primed. Okay, the derivative of my first term here will be 2 300t times 300 plus the derivative of this second term here, give myself a little bit of room, is going to be 2 70 minus 420t, okay, to the 1 times negative 420. Okay, so we got a lot going on here. Now, I can, at this point here, because each and every one of these terms has a common 2 in it, I can cancel those out. Okay, and then what I could do here is I can divide everything through here by d. Now, at the same time, I'm going to do a little bit of simplification in here. Okay, so I will get that d primed is going to equal, well, this is going to equal, what is it, 90,000 t. I'm going to get, what is that? It's going to be, whoops, 70 times 420. That'll be negative 29400. That's just going to be the 70 multiplied by the negative 420 here. Then I'm going to get that negative 420 and multiply by the negative 420 here. Okay, so 420 squared essentially. And this will be plus 7, whoops, sorry. I was saying it, but I wasn't writing it. 176400t. And this is all going to be over d. Now, that's a little bit of a moot point though, because what I want to do with the derivative, now that I've got the expression for d primed, I want to set this thing equal to 0. That's how I maximize. Okay? So now, what we're going to do is take, what do we got here? Again, I got to just make sure I'm looking at the right thing here. I'm going to take that 90,000 plus the, what is it, 176,400. So that is going to be, well, basically that ends up being 9 plus 17. So 26, so 266400t minus 29400. I'm multiplied up by that d, so it's gone. And so now t will equal 29400 divided by 266400. And the answer is 0.11. Okay, now that's 0.11 hours. Now we might convert that to minutes if we really wanted to, but that is probably good enough for what we need in the next question.